Hi all, and welcome back. Today I'm going to be walking us through assignment 7. Now, this may be the last assignment I walk through like this, because after this one you will have done 7 assignments in R. And so at this point, I think you should be getting comfortable with, at minimum, the basics of starting up an R Markdown file, reading in data, loading in libraries, things like that. And you should also be familiar with how to map the instructions to actual code that you're implementing in your assignment. So keep that in mind for after spring break. I'm going to try to wean you guys off of it. But I know this is kind of a beefy assignment, so I'm going to go ahead and walk you through the main points of it. I haven't done the whole opening up our Markdown. I'm assuming you know how to do that at that point. So I'm just going to, for time's sake, jump straight in and assume that you have pulled up your R Markdown file. And I'll go ahead and save it. 0227. I never remember how I want you guys to save this. Ducate. 305. Assignment 07. Alrighty. I'm also not going to summarize the things that you should be able to do from past assignments. Basically, if you hit anything that you don't remember, you should go back to assignments 1 through 6 to find them, because there's a lot of things that you've learned at this point that I'm expecting you to remember moving forward. I'm also expecting that you have watched the lecture video for this week, and that you've done the reading. All of those things are going to be super important for this assignment more than others, because while many of you might kind of be familiar with things like central tendency or frequencies, and you can maybe sort of skirt by without looking at all of that stuff, this week we're moving into probability territory, and that's a little bit more complicated. We're also moving into z-score territory, and that's definitely a bit more complicated. So make sure you do the background reading first. Also make sure, I realize that there's a lot of preamble to this particular assignment about like probability and the movement from descriptive to inferential statistics. Do make sure you read that as well. That's not just superfluous, that's also set up, that's also part of teaching you this probability inferential statistics stuff. So please do read that as well. Okay, so the first thing we're going to do is let's see, part 1, assignment 7.1. We do our standard this R markdown file. Where is it? Down. Document contains blah, blah, blah. You know how to do that bit. You are then going to, oh, sorry, this should be a second level header. That's what I told you. Load libraries, insert an R chunk. And let's see what we need here. Let's grab a few from this first one. Because we need tidyverse, Haven here, sjmiss, sjplot. We do not need summary tools this week, but we do need a new library called rstatics and a new library called, I've typed that wrong. There we go. GT. Well, GT is not new. You should be familiar with that. You might need to install this if you haven't already. Go ahead and load those libraries in. We can then minimize this. Alrighty, next thing we're going to do, read in some data. Or read data into R. We're going to be reading in 2 data sets, the NCVS lone offenders data set and the states data. So to save us time, I'm just going to copy paste that. And go ahead and load those in. You can see they show up here. So states data is 50 observations, and CVS data over almost 24,000 observations. We can go ahead and highlight and press Control Enter or Command Enter, depending on if you're on a Mac or a PC, just to make sure that it worked. All looks in order. So the next thing we're going to do is make a crosstab. And there's a lot of description about what a crosstab is, how to interpret them, etc., etc. Let's see. Well, we're not quite at that yet. Okay, so let's go ahead and make just a level 3 header. And let's call it crosstab of relationship and mail off. There's a whole bunch of explanation about how to actually read these crosstabs, which I am not going to totally get into. What I want to show you how to do is make the code. And actually, I'm realizing now I don't have you do this one yet. That's in the next section. We're going to be using the NCVS data of private location and reported to police. Okay, and so the way we're going to do this is we're going to pipe our NCVS data. Remember, you can press tab to autocomplete, then insert this little pipe. For a lot of the code we've been running, we've been typing it all on the same command, but when you pipe something, you could actually then put your next code on the next line. You'll notice it's fussing at me because I don't actually have anything written on this next line yet, but it will calm down once I start typing more. We're then going to filter out the NAs essentially. And so R has this cool little function called just is NA, and it literally will just tell you if there's certain values that have NAs in them. Oops, not happy about that. So doesn't really have NAs for this particular one. But we want to filter out everything that is NA. This little exclamation point just means not, like it negates this. So it's saying, okay, this line, let me finish, reported to police. All this line is doing is it's saying, okay, what I want you to do, and you read them usually from the inside out, is an easy way to deconstruct your code. You're like, okay, I want to see for this variable reported to police, is each one of them an NA, so a missing data, or is it not? And so by itself, this is NA is going to report trues and falses, where true means is an NA and false means not an NA. But putting this, what we call like a bang or an exclamation point, negates this. So it's basically looking for all responses that are not NAs, that are not missing. And we're saying filter those out. Like I just want those. So get rid of all of the NAs, please. Then I'm going to make a frequency table, private location, port, port NAs equals false. And we'll turn this into a tibble and then pipe it to GT. Oh, it does not like that. Why does it not like that? Watch me troubleshoot in real time. Oh, because we do need summary tools. That's why it's angry. So if you're wondering how did I know that? It's because up here it tells you which package the function is from. And so in this case, the function is from summary tools. So I'll have to fix this. Let me make a note to myself. And so what this told me was that I needed the package summary tools in order to use the function TB, and I didn't have that. And there we go. Now it works perfectly fine. And we can do, let's see. Actually, I realize why I'm confused. I have these mixed up. It's the downside of doing these completely live. So let's try this again. So this is what you should actually have, which is also what's in your assignment. So the NCVS data, pipe it to this filter command. So we're basically filtering out missing data. We should filter out missing data on the variable of interest. We can then calculate the frequency table for this. Turn it sort of into a tibble and then pipe it to GT to make it pretty. Again, we don't always have to do that if you want like this table. Just depends on your particular needs. We can then reuse this code, but switch it out for reported to police. And again, these are at the moment just simple frequency tables. So we're just trying to get a sense of the data before we start doing cross tabulations. Say, okay, there's like, of all of the people that reported in the NCVS data or reported to the NCVS data, fewer of them didn't report to the police than did, at least of the data we have. So about 54% of people reported to the police and about 45% didn't report to the police. So note that there are some other things we could have done other than filtering based on NA to get a pretty similar effect. So for instance, you can use, make another R chunk. I go ahead and minimize this. You can, for instance, just use NCVS data, use the summary tools frequency, and just use the report NAs is false. So essentially, this is kind of redundant. So you could have allowed it to report NAs, but you're filtering them out, so there would be none. You could also just do it in one straight step. But it will work the same. GT. And there we go. And so you can see, just to prove this to yourself, this table looks the same as this table. So, okay, now we're going to get into actually making some contingency tables. Okay, scroll. And so to do that, we're going to skip down to part 2. So the rest of part 1 is really just explaining how to read contingency tables. So I suppose if you're comfortable with that, you could probably skim past it, but it does explain things like, where to put independent and dependent variables and how to read them and how to calculate joint frequencies. Again, some of that overlaps obviously with what you'll be reading in your book and in the lecture, but it's just one more avenue to learn about it. But for actually creating a crosstab code-wise, we're going to go to part 2, assignment 7.2. And we'll be using sjtab to do that. So actually, let's go ahead and create a third level header. And we're going to call it cross tabulation of gender and relationship. So So we're going to use the NCVS data again, pipe it. We're then going to just select two variables, relationship and V, was it 3018? If you're thinking, how could we possibly know that that's what that is? Remember, you can use the view df and V3018 is going to be for sex, is what this tells us. So gender, sex, I'm sort of using those interchangeably. And then the variable relationship tells us relationship. And the reason we have these flipped is so that the dependent variable is in the rows and the independent variable is in the columns. We're then going to pipe these, pipe these to SJ tab. And we're going to give it a title. Cross-tabulation of victim, gender, and relationship to assailant. Go ahead and show column percentages. And then we don't need to use the viewer. Okay. Oh, it is not happy with me. Oh, because I have a typo. That's why. I always got to check for typos. Even I make them. Actually, I do want to use the viewer. This is not helpful to you. Okay. So this is the output you get. If you use the viewer, it's going to pop up in your HTML or your web browser. Same thing. Alrighty. And so what this is giving you is your what we're calling the crosstab. So it's saying, okay, there are in this entire sample of 23,300 people, there are roughly 4,600 of them that were male that were attacked by a stranger and these one-off things. It's also going to tell you these percentages, and these percentages are column percentages. And so the previous part describes a bit how to interpret these. But as a quick summary, these are column percentages, which means that this number is calculating the percentage of males that were attacked by a stranger. So you'll notice that these numbers are going to add up to 100. And similarly, these numbers are going to add up to 100. And similarly, these are going to add up to 100. So just keep that in mind, that this isn't 38% of the entire sample of males and females. This is just 38% of the group of males. And so with this, you should be able to do some calculations for this part of your assignment. So you can do things like calculate the probability of being a participant being female or being attacked by a stranger, being male or being attacked by someone they knew well, probability of being attacked by a stranger, et cetera, et cetera. So you should be able to do all of these probability calculations with the crosstab that you have just created. And so we're going to skip down to part 3, where we're doing something a little bit different. We're going to be conducting a binomial hypothesis test. 3. And so we want to infer if we're going to want to conduct a binomial hypothesis test. So again, if you're not comfortable with that, or if you're a little bit not yet fully on board with the concept of binomial hypotheses tests, go back to the video lecture, go back to your book, and reread/rewatch those sections again. Because we are trying to infer whether women are more likely than men to assault someone else in the US population. So we're going to be using the male off variable, which records the victim's report of the sex of the offender. So 0 means a female offender, 1 means a male offender. And we're going to have a null hypothesis of 0.5. Okay. Conduct a binomial hypothesis test. And so we have to specify a null hypothesis. In this case, we're going to specify a null of p equals 0.05, or yeah, t equals 0.5. Sorry, not 0.05. Because our null is that there's going to be an equal proportion of men and women, that 50% of the reports are going to be male offenders, 50% are going to be women offenders. We then need to establish an alpha level. Again, I'm mostly giving you some of these. So we're going to set alpha at 0.05. What this means is that we're willing to tolerate a false positive rate of up to 1 in 20, or 5% of the time of being wrong. We then need to grab our x's and our n's. So x is the number of trials or observations that we're analyzing. So in this case, number of assaults committed by female offenders, whereas n is the total number of observations. So for both men and women. So we're going to go ahead and just create a simple frequency table to get those numbers. Oops, there we go. So we can see our total n, and it actually is calling it n because that's a super common way to refer to samples, is 23,969. And of those, 4,700 or 4,800 are females. So this becomes our x. This obviously becomes our n. Just as a side note, you'll notice that the mean is 0.8. Which seems to correspond pretty well to the proportion of ones, or the proportion of men in this. That's what happens with binary variables coded as 0 and 1. If you take the mean of them, you will actually get the proportion of people coded as 1, just mathematically. So as an FYI. Remember, we have 2 different ways we can do this, so we could have also done this. Whichever one you prefer the output of to this. Okay, now we're going to do our actual binomial test. And so we're going to type binom test. Note that there are like other binomial tests. We're going to use the rstatics one. So our x is 44798. So we have to do this manually. Our n equals 23969. And if you're thinking to yourself, gosh, I wonder what all of the arguments I could put in are. Remember, you can type this over here. Type in the question mark followed by the command of interest, and it will tell you what your options are. So note that it is defaulting actually to p of 0.5, so 50-50 chance. But because we want to be reproducible and be explicit, we're actually going to type that in ourselves. And it's going to be, we haven't quite gotten to this yet, but it is a 2-sided test with a 95% confidence level. And it's not giving us a detailed output. And we could probably check here to see, oh, I wonder what detailed means. We could try it both ways just for funsies. Okay, so here's our output. It's giving us this particular estimate. But the next thing we want to do is make this look a little bit less ugly. And so we're going to do GT, run that whole thing. And so we get this as an estimate. So we're not going to talk too much about like how exactly to interpret this yet. Although we are going to make it prettier. So GT has a couple of other options that you can do. And so I just tell you a couple of them. There's tab header. And we can put title equals, I'm a bit too lazy for this. Title equals this. This MD just means you're writing it in Markdown. So you guys should be familiar with Markdown. We've been using it in our Markdown folders. Things like the double asterisks are going to bold text for you, is all that's doing. And then we'll put a subtitle. And rerun it, and look, it's so much nicer, so pretty. And so the next thing we want to do, what a lot of people will jump straight to, is trying to interpret this p-value, because we're trying to see, is it significant? And there's all these stars here, which make it seem very significant and very important. But we want to kind of turn this potentially into not scientific notation. And so what you can do is type in, you can type it kind of anywhere. Say options. There's lots of different options you can set in RStudio. We mostly won't fuss with them, but you can do SciPen 999, digits equals 3, and then did not like that at all. So you can see this is quite small and quite crazy. So that's part of why it puts it in scientific notation, is your p-value is super small. So we're going to go ahead and turn that off for now. 0, digits, 7. There we go, much better. Now, the takeaway from this, I sort of just tell you in your assignment, what this means is that this p-value is very small. It is much smaller than 0.05. And since 0.05, and don't confuse it with 0.5, but 0.05 was the kind of error rate we were willing to tolerate. It was our alpha level. Our p-value is like way smaller than our alpha level. So we can go ahead and reject the null hypothesis. And so the next thing you have to do as it relates to your assignment is to walk through this yourself. I do want to see, even though I'm telling you a lot of what to do, I do want to see that in your Word document, you actually working through. I want you to specify your values here, and then I want you to tell me what your conclusion is. So what is your decision in regards to this binomial test, and what does it mean? So interpret it for me. Okay, we're almost done. Hang in there. Go ahead and minimize this, and we're going to move on to part 4. 7.4. Okay, so for this last bit, you're going to calculate z-scores. They're not actually that hard to calculate by hand, but if you want to do a bunch of them, it's nice. And so we're going to reading histogram for murder RT. And note that we are now switching to working with the states data at this point. So before, for everything prior to now, we're working with the NCVS data. Now we're working with the states data. And so just to get a sense of what our data look like, we're going to go ahead and just states, there we go. Make a little histogram. So you guys should be familiar with this at this point. As a note, I tend to accidentally pipe at this point. Geom histogram, yes, x equals murder rate. And it'll pop this this error out for you. But if you pay close attention, it actually is telling you something useful. It says, did you use the pipe? Or this is like R's built-in pipe now. Did you use the pipe instead of a plus sign? I do this regularly, and I regularly go, oh yes, thank you, tidyverse. I did use the pipe instead of the plus sign. So make sure you're getting that right. The plus sign in this case, you're not actually piping the output to geom histogram. You're actually stringing together a series of arguments. So you're piping the states data into the string of arguments. Okay, whatever. And so here we get this kind of cool histogram of distribution of murder rates across 50 states. And so next thing we're going to do is we're going to create a new column where the murder rate is going to be converted to z-scores. Converting murder rate to z-scores. Okay. So we're going to just select the two columns that we need and put them in a new, basically data object. This is not strictly necessary, but it does make things a little bit cleaner. State and murder rate. And so you'll notice we now have this new data object here, also with 50 observations, but it's only got 2 variables now. So much easier. Now, there are a whole bunch of ways that one could convert these raw scores to z-scores, and I walk you through a couple of different ones. So I'm going to skip a little bit. Well, no, I won't go ahead and skip. We'll do it the long way. So one of the things you could do is you could get the descriptive stats. But that's not right. There we go, from summary tools. What you could do is you can get these summary stats, and then you can, oops, make sure you grab the right one. Data sub, type that. All this is going to tell it to do is any changes we make to states data, it's going to put it into type it back or feed it back in to the same data set. So we're making a new column. We want it to put that new column into the same data set that we piped into the creation of the new column. So we can do mutate, and mutate is a tidyverse command that helps us create new variables. And so we can do z murder rate. You can also put this on a new line if you just want it to be clean. I tend to like that. And so what you can do is you can say for each value of murder rate, I want to manually subtract the mean, because remember z-scores are score minus mean over standard deviation. So we're just going to essentially type that out. So for each score, I want you to subtract 4.51 over 2.41, which is our standard deviation. And then I'm gonna states data sub, just grab the head, and then pipe it to GT to make it pretty. Okay, so we can run all of that. And we have this column for murder rate. And like, that's cool. But it meant that we had to do a bunch of different things, including manually typing in numbers. And ideally, you want to let R do things like that for you. You don't want to manually type things in when you can avoid it, because you might make mistakes. What if you accidentally typed 2? What if you flipped them around? I do this with numbers all the time. I flip numbers around. And so this is not always your best strategy. And so something else that you can do, and you should be doing these sequentially, I'm just going to redo them up here, is remember that R has a built-in function for calculating the mean. So rather than like looking up the mean and typing it in manually, you can actually just put the mean here. You can then, instead of manually putting in the standard deviation, you can just put in the standard deviation here. And what you will notice, so watch this kind of carefully because I'm going to run it all at the same time. It's the same thing, gives you the same output, but this is essentially more reproducible. It's a little bit less likely to result in errors. But the last thing we can do, so this is useful just to show that you can actually type out formulas and make calculations yourself. So if you've got some kind of complicated formula that you're trying to calculate, you can use the same general template, but put in whatever weird formula you want to change your values to. But there's actually a nifty-difty scale function built into R, and you can just type in murder rate and essentially scale, come on, base R function, and it says its default method centers and or scales the columns of a numeric matrix. So it essentially turns them into z-scores. There are other things that it can do, but by default, it's going to turn them into z-scores. And so watch closely again. Again, same thing. This is just a nice clean way to do it. So again, I want to see that you can do all three versions, but at the end of the day, like in the future, if you're being asked to calculate z-scores for things, or convert something to raw scores to z-scores, you can just use this scale command. I think that's the easiest thing to do. Let's see. And so with these z-scores, you should now be able to use them to do some of these calculations. So I say, hint, draw out the normal curve by hand on a sheet of paper. So you've used R to convert your variables for you, which is very nice. But it is now up to you to do some more manual calculations for z-scores. So for instance, the first one asked you to calculate the proportion of states expected to have a higher murder rate than Alabama. So we can see we've got this z-score for Alabama, 1.072. And so you're going to use this as your z-score. You then need to go through the process of like looking up the z-score on the back from the back of your book. It's going to tell you what we call the mean to z proportion. So the proportion of scores that fall between the mean value of 0 and the z-score, in this case, of 1.07. But then you're going to have to do a little bit of math because I don't want to know what proportion of states have a theoretical murder rate between 0 and 1.07. I want to know what proportion of states are expected to have a higher murder rate than Alabama, so above this value. And so draw it out. You have enough of the pieces that you can figure out that last piece. And you'll use the same kind of logic for question 16, where you're trying to compare z-scores between Alabama and Alaska and figure out what the proportion of states are expected to have a murder rate between the two of them. So I realized it was a little bit meandery. This particular assignment has a lot of explanation to it, so it took me a bit to pick out the most important bits to show you. Please do take your time through it. Do read the different explanations. I think it will help. But as usual, email me if you have questions. Next week, just as an FYI, will be the first week you will not have one of these videos because it is essentially a review week. And so you can come back to these videos and go back to the assignments to figure out how to do the things that I'll be asking you to do because it will all be review. And then starting after spring break, I'm going to try just giving you the assignments without these videos, and we'll see how it goes. If it's a complete and total disaster, I'll rethink that. But I do think at this point that you guys have enough experience working with R that you should be able to follow the written instructions now and not necessarily need to see me write it out. Okay, that's it. Good luck. I know this is a long assignment, but in terms of actual code you have to run, it's not that much. So I think you got this.